Hi, welcome everyone. I see a lot of people and a lot of attendees are currently joining. So welcome all. Let's give 1 or 2 minutes, 1 minute for everyone to finish joining the session. I hope you can all see my screen right now with the cover. So welcome to this webinar where 5 smart and sustainable energy projects, SOWOT, Embers, Incubis, RACES, and Sparks, will be talking about waste heat recovery and energy cooperation in European industries. So we have these 5 sister initiatives that have been funded under the European Union's Horizon 2020 Research and Innovation Programme, and they will be presenting their work on industrial waste heat and cold recovery, the tools that they are developing to empower it, and potential synergies between industrial parks and the surrounding community. So this is the agenda. Well, first of all, as well, please be aware that this session is being recorded. We will be sharing with you all the recording of the session as a follow-up during the days after this session is completed. This is an interactive session, so we would really appreciate your participation. We want to hear from you, and we want you to be active. So please use the chat function to enter your questions. The microphones for attendees are off, but please, any concern, any question, any comment, use the chat, and we will be really glad to help you all answer these questions or concerns. Just for you to also be aware, if there is any question we cannot reply during the session, we will be replying to those during the follow-up, also together with the recording of the session. And then let's go for the agenda of today. I hope everyone has joined by now. So this is the agenda that we will follow. We will have this brief introduction, and then I will be handing over to my colleague, Francesco Peccianti from RINA Consulting. He's the project coordinator of SOWOT, and he was the one organizing this webinar. Then we will have Eric Lecomte, a policy officer at the European Commission, who will be providing an overview on waste heat and its importance. After that, we will have the Cooperation and Industrial Parks session, where we will have Andrea Coleman from the Energy Institute of the Johannes Kepler University Linz, in representation of the X-Parks project. We will have Giorgos Chalkias from IDIS Technology Solutions representing Incubis, and we will also have Peter Verboven from Condugo in representation of RACES. And then Francesco will be also, I have already introduced him, he will be moderating this session as well. He will be mainly the moderator throughout the entire webinar. Then the next session will be Tools to Empower Waste Heat Recovery, and this one will count with the participation of Nick Purshouse from Integrated Environmental Solutions, representing the SOWOT project. We will also have Lola Maynard from Fundación Circe, representing Sparks, and Zenaida Morao from the Portuguese Institute of Science and Innovation in Mechanical and Industrial Engineering. She is representing Embers. And then last but not least, Francesco will present some of the conclusions of this session, and then we will have an opening for questions. This said, I would like to remind you again that you can write your questions on the chat anytime, and we will try to reply them. And those which we don't manage, we will be sending you the answer in the follow-up of this session together with the recording. And now we would like to see who is connected, get some brief information about you. So Francesco, please, you can launch the poll. So we would like to know which kind of organization are you coming from. You may come from the industry, you may be part of a public body, you may be an ESCO or a consulting company, you may be from a research institution, or maybe you are not any of this. You may be a student or just from some other type of stakeholder. In this case, please click Other.
Okay, I will share the results. I can see there is quite well distributed. This is Francesco speaking. I can see good amount of researchers probably, and all the other categories were represented. I'm glad of it. And well, now I will just present you some introductory slides, and I will be then going to share my screen. Okay, you should be able to see it. I would ask the other presenter just to close their camera to improve our connection. So today we are going to, as Anna presented, there are 5 projects represented today. All of them are H2020 funded projects, and all of us, we are tackling the challenges of waste heat and energy cooperation. Then we are glad that Eric Lecomte from the European Commission is here as a big part of all these projects to present why we are doing this, and also the challenges and some overview of the next years from the European Commission perspective. But why are we talking about all this? Basically, I would say that now we are dealing with environmental issues all over the world, and air pollution is the major cause of premature death and disease, and the single largest environmental health risk in Europe. This is from the European Environmental Agency. So now we are, all of us, dealing with coronavirus pandemic, all restrictions related to that. But the air pollution is quite a big problem for all of us. And even though the modern society, as we know it, is based on fossil fuel, thanks to the Industrial Revolution, and they played the biggest part probably for where we are now. Now we are phasing out of them. We should do it. We see that the part per million of carbon dioxide in our atmospheres are at the highest point in the last 1,800,000 years. We are not sure what does it mean. It's somehow controversial how much is human related and which will be the impact, but this is something very relevant, and we know that fossil fuel contributed in large parts to it. And indeed, even though when we think about pollution, we might think to some cities in China or something, or some other highly industrialized areas. It is notable that us as Europeans, probably there is someone not from Europe today, I don't know actually, but we are well exposed to air pollution. We can see in this image from the World Health Organization that more than a large percentage of us is exposed to air pollution and somehow exceeding the EU limit or target values or the strictest guidelines of the World Health Organization. That said, energy still represents the backbone of our life and a large cost for energy-intensive industries. Today, the focus will be mainly, but not only, on the industrial part. Of this energy, which is a cost for the environment and for the pocket, a large amount is lost in the form of waste, which a part of it, at least, can be recovered. How, it is something you will probably see, you probably know already, but you will see in the next hour or so. In this sense, we can improve our performances in the industries and in the communities based on energy efficiency, which is part of waste heat recovery, and therefore cut our CO2 reduction, CO2 emissions. And in this sense, not less important, what we can also obtain is to increase our competitiveness in this moment, which is quite difficult for the industry around the world. That said, I hope you will find this webinar interesting. You will see that these projects are someone already started from a while, some other just started, and we are working on collaborating. And we hope that you will find everything interesting. Now I am heading over to Eric Lacomte. He is a policy officer for the European Commission, and he is in charge of several files from industrial energy efficiency and transition to carbon neutrality over the top. So Eric, thank you very much for joining us today, and the floor is yours. You should be able to share your screen.
Okay, good morning, everyone. So I will share my screen, and well, can you see the presentation appearing?
Yes, I do.
Yes. Okay. All right. So it's a pleasure for me to talk a bit to you about the energy policies, and in particular to which extent they have an impact on waste heat recovery, or maybe better said, how waste heat recovery can contribute to the EU energy policies. And so you certainly have heard about the higher ambition that was announced recently to at medium term, so by 2030, to reduce the greenhouse gas emissions by 55%. And yeah, maybe I have to. So excuse me, because I thought that you didn't see the complete screen, but what have I done now?
We can see the presentation well now, I believe.
Okay, all right. I can't see it anymore. I've lost it somehow. But yeah, that's a bit. What can I see?
We are seeing the 2030 climate target plan slide now.
Okay, actually I see myself now. I clicked on something I should not have. Oh yeah, okay, all right. So
Eric,
you see that,
we are not seeing it currently.
can you see the screen now?
No, we only see you.
Oh, that's okay. Because now I can see my screen, but you don't.
Maybe if you don't have it, if it's not working, maybe you can have it as non-full screen. Maybe that would help somehow. At least we can see it now, but we can see it with the comments and everything. Now we don't see it.
Yeah, okay, now do you see it now?
We do.
Okay, but not full screen maybe?
No, not full screen.
And now do you see the complete picture?
Yes, we do.
Okay, all right. So sorry about this technical hiccups. So as you can see, this intermediate point at minus 55% by 2030 is approximately on a line towards the climate neutrality in 2050. So that's why we found it this important, that in order to reach the neutrality, we definitely need to have a medium-term target, which is 2030. And so this will be this has been supported by a comprehensive impact assessment to assess also the social, economic, and of course environmental impacts. And indeed, it's to launch the public debate so that we can eventually agree at European level to announce an increased contribution to the Paris Agreement, the COP. And so concretely, it would mean increasing the share of renewables. So presently we have a target of 32%, so going up to 38.5%. And for energy efficiency, going from 32.5 to 36%. And that's where, of course, also the waste heat recovery in industry has a role to play. And what is important in impact assessment is that we looked indeed at the impact on the industries of increasing the ambition. And it shows that the impact of this higher ambition is positive on the competitiveness of industries as being the leaders in those markets, and so that would also create more jobs because the companies would be more competitive. It's also developing more autonomy of the supply chains, as we have seen with the COVID crisis, that it's so important to have a kind of sovereignty. And so it will be by incentives for demand for renewable energy, for more electrification. So it means also that the production of heat, including in industry, will be more based on electrification, direct electrification, or indirectly through renewable and low carbon fuels, such as, of course, also hydrogen. And so this is important for you that you have to develop waste heat recovery techniques for industries that will change dramatically in the following decades, so to be kept in mind. And also what I wanted to share is that together with the State of the Energy Union, so in October, was published a competitiveness progress report and supported also by an analysis of the clean energy transition technologies and innovations. So again, with this context of COVID and recovery, it's not only to look at how the clean technologies can contribute to fight the climate change, but also to look at the competitiveness of the companies and also look at the markets. And you have the link down there to access that document. And indeed, it looked not only at technologies. You see the first column, not only those indicators, but also indicators about the strengths of the value chain in Europe. That is the second column, and also the markets, the global markets. So really, in a view of developing those technologies, also to create economic activity in Europe, competitiveness, and jobs. And so in that report, 6 main technologies were addressed, those ones that you see at the bottom. So offshore wind, ocean, PV, renewable, hydrogen, batteries, and smart grids. But also in the supporting documents, in total, 18 technologies have been addressed. And again, you have the link to access those reports. And it's split in several parts because there are so many technologies that it didn't fit into a single document. And you can see in part 4, the chapter 12 is about industrial heat recovery. So I encourage you to go and have a look and come to me with comments, because indeed that's an ongoing process. This is the first time that we produce this report, and we intend to have revisions every year. Okay, so that's the first point at the top left here. We about the main findings. We will further develop this assessment. I will not go to all of them, but on the right you see that the outcome of the finding of the analysis is that clean energy technologies are outperforming conventional technologies in terms of value added, in terms of labor and employment. So that's indeed very, very important. And then I wanted to also, well, this of course you certainly know that under Horizon 2020 there was a topic that's closed recently, so in September this year, about industrial waste heat recovery, but then conversion to power with either organic Rankine cycle or supercritical CO2 technologies. And so the evaluations are finished, and soon the results will be published. So these are projects managed by the agency INEA, and UR projects, if I'm not wrong, managed by agency EASME, but never mind. Okay, looking more into the future, so Horizon Europe, of course, the bulk of topics related to industry will be in the cluster 5, digital industry and space. So you see the word industry. So there, the presently running SPIRE partnership most likely, or should be indeed reconducted, so continued under new name, Processes for Planet. But also I wanted to tell you that also in cluster 5, climate, energy and mobility, there are some topics addressing industrial facilities in transition, and more specifically on the management of thermal energy. And so topics, well, this is still to be confirmed, still in discussion with the member states and associated countries. So that it will soon be finalized. Maybe some of you had access to drafts through the member state national contact points. So, but so four topics should be. So the first two ones are about heat upgrade. So heat upgrade. The first one is about technologies that are already more mature, so in the range of temperature 100 to 160, where some projects are running. And so now it's really to demonstrate them at full scale, so that the benefits can be really demonstrated and better deployed. And so by heat grade, of course, one of the main technologies is heat pumps. Then the second topic is the same, but addressing temperatures that are not yet covered today. And so going up to supply temperatures of 250 degrees. And there other techniques than heat pumps could enter into play. There it's rather a research and innovation action, as those technologies are less mature. The third topic is about thermal storage for industrial applications. And so I assume this is one of the components that are addressed in your analysis of waste heat recovery, being capable of storing the heat to use it, well, to store it when it is produced, and then to use it maybe later thanks to the storage. And then the last topic is similar to the one that we had on the Horizon 2020, so heat to power conversion. But as the previous course, so the ongoing, most probably will rather go to funding supercritical CO2. This time it would rather be based on ORC technology, so ranging, tackling rather a lower temperature range of waste heat. So that's what I wanted to yeah, okay, sorry, there's still another one. So and all of this contributes to one of the biggest chunks of the energy strategy, which is energy system integration, where indeed we look towards, we have 6 priorities. The first one is to go for a more circular energy system. with energy efficiency first principle. So that's really where the waste heat recovery comes into play. Circular in that the heat can be recovered within the plant itself. That's always the easiest, but also in industrial clusters to nearby plants or even to local communities for heating buildings in the communities. The second priority is accelerating electrification of energy demand. So it will mean that also the heat will be produced definitely, not only in the building sector, but also in industry. So again, an impact for you. Promoting renewable and low carbon fuels, including hydrogen. That again will reshape industry, energy and feedstocks. And fourth point, making energy markets fit for that. And this certainly is something that resonates for you if you address the business models. This really fits into the energy markets. Fifth point, integrated energy infrastructure, because of course to make all of this work together, we have to interconnect the various energy vector grids and better also interconnect the various geographical regions in Europe, so that we really generate the energy where it's the best place to do it, and then we either transform it, for instance, to hydrogen, then transport it to the point of use. So this is really an integrated infrastructure in which, of course, the digitization, and that's the sixth point, will have a good contributing function. Yes, and yeah, that's it. So thank you very much for your attention. I'm afraid that I won't be able to maybe follow it to the end. So if there is a specific question, maybe I could answer now. But okay, it's really up to you, the organizers of the
okay.
workshop.
Thank you very much, Eric. And now it will be Andrea Kollmann from the Energy Institute of Linz presenting. As we spoke about waste heat, now we will be presenting first energy cooperation, which includes, but it's not limited to waste heat. So, Andrea, you should be able to share your presentation now, and all questions in any case will be answered probably, if not during this session, later on.
Thank you very much, Francesco. My presentation, you can see it?
Yes, perfectly.
Wonderful, thank you. So hello everybody, my name is Andrea Kollmann. I'm from the Energy Institute at the University in Linz in Upper Austria, And I'm very happy to present you some insights into the project SPARX today, which I'm lucky enough to be the coordinator of. SPARX started in March 2018 and will continue most likely until June next year. We've just asked for an amendment to prolong our runtime, as many of you, I'm sure, also have the same issues right now in your Horizon projects. COVID has made many things very difficult, especially in a project like ours, which is all about cooperation. We are a consortium of 12 partners from 6 different countries: Portugal, Spain, France, Austria, Italy, and Turkey. Our team consists of 2 universities, 4 research institutes, and a communication expert. And at the very core of our partners are 5 lighthouse industrial parks. These parks, we have 2 in Austria, Enshaven, which is a port and a mixed business park at the river Danube, very close to where I'm living in Upper Austria. We have the Chemie Park Linz, which is the largest chemical park in Austria that hosts some very big companies. The biggest one there is Borealis. Another park is in Ponte Aiguola, which is near Pisa in Tuscany, And this park is particularly interesting because it is the center of the Italian leather industry. And then we have two more parks, and you can see them down on the right. They are in a rural setting in Basque Country and also are mixed business parks. What are we aiming for? Well, our goal is to develop replicable instruments for energy cooperation and to provide industrial park managers as well as single companies in industrial parks with all the tools needed to make energy cooperation solutions happen. Our work covers everything from the development of business models to the design of templates for contracts. We are currently working on policy briefs about national legal and regulatory frameworks, specifically for Spain, Austria, and Italy. Francesco, who's our moderator today, is in charge of these activities, and we will be starting to disseminate them later this year. In addition to what we did with Energy Cooperation, we developed an online platform that my colleague Lola will talk about later today. So let me give you a brief overview of how we approach the topic of energy cooperation. The first thing was to identify potential solutions for industrial park. And we were quite successful in that and identified 41 of them, which we then clustered into 5 different categories. So we cover solutions that are managerial actions, we cover contractual instruments. We also, of course, look at physical installations, the installation of new monitoring, new ICT infrastructures and technologies. And a big part of the solutions that we've been looking at also deal with logistics and mobility solutions in the park. Pretty much all of the solutions that we've looked at could also be doable by a single company alone. What is interesting for us, and what was also the focus of our analysis, is how the cooperative implementation could make them more efficient and lead to win-win situations for all the partners involved in such an energy cooperative solution. What we did then in the next step was to match all of these solutions with possible barriers. We knew from the beginning that there must be many different reasons why there aren't more energy cooperation projects ongoing in industrial parks. Again, as you can see, we clustered all of our barriers, obvious economic barriers, social managerial barriers, things again like legal and regulatory framework issues. We touched upon technical and engineering related barriers, and finally a big topic in all of our projects and in all of our parks is the question of information provision and the sharing of data between companies that might be in a competitive situation with each other, and how we can overcome such a barrier when it comes to implementing a solution. All of this we didn't do only as desk research exercise, but we actually went out into the parks and all of them and conducted dozens and dozens of interviews with park managers, with the head of companies, to find out what their perspective on energy cooperation actually is, what they find particularly interesting, what they find to be the most important barriers for their situation. As you may know from other comparable projects that were done in the past, especially about industrial symbiosis, this social, organizational, and information provision barrier has also proven to be the most important one in our project and from all the talks that we had with companies. Next up, knowing about solutions, knowing about barriers, we of course went on to try to find instruments to overcome these barriers and to support the actual implementation of the solution. What we saw is that obviously the most valuable instruments are those that are transversal both to the various barriers within a cluster, but also across all the clusters that we've identified. Examples of such instruments include training and awareness raising activities, which is something that we are doing. And above everything else, the most important tool for us in the project so far has been to have workshops in the parks to enhance communication between companies, to actually bring companies together so that they can exchange their ideas, their visions for the future. This is not necessarily something that companies know of each other, especially when energy is not the most important aspect in their actual production processes. Another important aspect that I would like to mention today, because I know that this is something that pretty much all industrial projects deal with, and these are key performance indicators. We also found that in addition to being able to quantify solutions from an economic point of view, from an energetic point of view, KPIs can be a very valuable tool in an ex-ante situation for a company or part thinking about implementing energy cooperation solutions. And especially to have a tool that allows them to compare different options from a number of different perspectives. And we came up with 6 different types of indicators, organizational ones, financial ones, but also environmental ones. When you look at our latest deliverable, for example, we also did LCA analysis for many of the solutions that we've looked at. Finally, and this is just one more slide, Francesca, then I'm done. This is where we are right now. Actual feasibility studies in the 5 parks that we are looking at. We've just published the deliverable that gives you an overview of these feasibility studies. And as you can see, we took a deep dive into very different solutions, from installing small hydropower plants to joint charging stations. Thank you all very much. And as I said at the beginning, you will learn more about SPARX and the tools that we've developed later on. Thank you, Francesco.
Thank you very much, Andrea. And thank you. Now it will be the turn of Yorgos to present. He's an innovation program manager at the IRIS Technology Solution, and he will be present Incubis project. So please, Yorgos.
Good morning, everyone. I don't know if you can see my screen already.
Yes, we do. Thank you very much.
So excellent. So good morning. Today I will be speaking to you about Incubis project, as you can see in your monitors, hopefully. So very quickly, to give you an introduction, as you can see from the title, Incubis is concerned with industrial symbiosis, utilization for maximizing waste heat cold efficiencies in industrial parks and industrial districts. We are a project that started last May, and we will be operational for 3 years with a budget of approximately 2 million, to give you an idea of the size of the project. We have a consortium of 8 partners, 6 of which are SMEs, 1 of which is a large company, and 1 a university. And we operate over 6 different European countries. I will not waste more time on this part. I just want to introduce very quickly our main, the background of the project, the main concepts involved. So Incubis is focused on energy symbiosis. So what could that be in very simple terms? And you had a small reference to that in the previous presentation from SPARX project. Energy symbiosis refers to the exploitation of energy efficiency opportunities found across industries and sectors. So we're looking basically at heat recovery and in general waste energy exploitation between different industries and between different sites, not within the same site. Now, energy symbiosis has been around for quite a while now. It's not a new thing, but it has some barriers that prevent it from reaching its full potential. The main barriers, there is a very long list of barriers and problems, but I want to just mention here the main things. It's mostly an issue of risk management and of risk, which is concentrated mainly in the project development phase. So we have a very high risk in developing energy symbiosis projects, and also we have very low risk tolerance from the stakeholder that would invest in these projects. In the project development activities, I mean. And finally, these stakeholders also lack the skills or the capacities or the resources to conduct properly risk management. As a result, we have projects that are often stuck at the project development phase and are never delivered. The solution is known and it is quite successful. So the solution is the existence of an intermediary organization called facilitator often, who has the structure and the capacity to overcome these problems and deliver the projects. So what is the goal or the vision of Incubis is that we have to somehow increase the number of organizations that can actually systematically develop and deliver energy symbiosis projects. And therefore, what we do is we follow the incubator model, whereby we're not incubating any type of business, but specifically we are aiming at organizations that can be facilitators. We are going to develop we are developing currently, and we are going to launch as of May 2021, the Energy Symbiosis Incubator that will provide support to these organizations that can act as energy symbiosis facilitators, with the aim to improve their capacity, obviously, to deliver energy symbiosis projects. In doing so, we will also set up a virtual platform that will support the delivery of all the tools, services, and methods of the incubator, and will also support the organizations we are helping to deliver energy symbiosis. You can see here that our model basically, I will not go in detail through all the services, but our model is to launch such incubators in 5 regions across Europe. And maybe here you can see the regions are in Barcelona, Spain, in Dunkirk of France, in the Hull region, in the Humber, region of the UK, in South Norway, Agder region, and in Brunsbüttel in Germany, in Brunsbüttel city and industrial park. And the type of services and methods we are delivering here involve techno-economic assessment, business development, implementation frameworks for symbiosis, facilitation methodologies for delivering symbiosis, and of course working across training policies and impact monitoring for these projects. And you can see in this scheme which partners are responsible for what type of service and tool. The approach we are taking here is that we are working on case studies that existed before the beginning of the project. We are learning from them, and as of year 2 and 3, we intend to multiply these energy symbiosis projects in the 5 areas of the project, and hopefully by the end of the project work also outside of these areas. And what we are doing is that for each energy symbiosis project, we are providing support across the life cycle of energy symbiosis, which is, I think, the typical life cycle of an energy project involving a preliminary assessment, opportunity identification, feasibility study, and finally delivery and implementation. Very quickly, I want to say that the target audience here, so basically who can be the facilitator? It's a big variety of organizations. They can be private organizations like, for example, energy service companies or district heating operators. They can be cluster managers or industry associations. They can be also chambers of industry and local governments. So we are aiming at all these organizations as possible clients, let's say, of our service. And we have also, I don't want to go in detail here, a number of impacts that we are estimating we will achieve, both in terms of primary energy savings triggered by the project, but also in terms of investment in millions of euros, as well as how many businesses and parks we will work with to deliver those services. And I think this is from my side. I don't want to stay for too long. You can contact myself and Emil Lezak for more information, or you can find us in our website, LinkedIn, and Twitter accounts. Thank you very much.
Thank you very much, Giorgos. And all this information will be shared with the audience after this webinar. Now I'm giving the floor to Peter Verboden. He is the co-founder of Condugo, and he has a wide experience in the energy sector in Europe. And he was the founder of the National Energy Cluster Flux 50 in Belgium. Peter, yes, we can see your screen. The first slide. Perfect. Thank you very much.
Maybe Peter, you can turn on the camera. because we cannot see you. We can see you now, but we cannot hear you yet. So please check if your microphone is unmuted.
No, we cannot hear you.
No, we can't hear you. Maybe you can try to reselect your audio. Okay, now it's working.
Yeah, it was working. I was checking it before, and then all of a sudden it went away. Okay, good morning, everyone. The RACES project. The idea of this project is that we want to make sure that there's a future for industry in Europe, and there can be two realizations. A, industry should step up its act on sustainability, and B, it could not do so alone. So the entire concept of what we do is trying to create eco-regions where we actually take an industrial site as the core of an entire region and then connect it to its surroundings, connecting it with a 4th to 5th generation district heating and cooling network with renewable energy and with a smart energy control system to tie it all together. The goal of RACES is not just to develop this concept, but really to roll it out, to make sure that it gets applied everywhere, that it gets implemented all across Europe, and make sure that we save at least 10% in CO2 emissions. The goal here is rather, I would say, ambitious, but we started with a list of 90 high potential areas, which was identified on the European Thermal Roadmap. And of those 90 areas, 3 are in the consortium. So we are working with 3 industrial sites that are really developing into such eco-regions, 1 in Denmark, 1 in Belgium, and 1 in Italy, the north of Italy. The most important thing in this project is that we work on the non-technical barriers for creating such areas. So we really try to get areas where there already is potential to the stage where they can interconnect their business park with their surroundings and actually save the CO2 in the end. What we offer here is support. We really offer support by setting up learning communities, clubs of people in and around those areas, and we support them with methodology, but also with 3 concrete tools. One is a self-assessment tool, which is really the kind of quick scan where you can gauge how far you are along in terms of building an eco-region, whether the collaboration networks are already there, whether you have an experience with such project, whether there's support from government, and so on. The second tool, the legal decision support tool, is one that many of you will recognize. If you want to set up collaboration, you will have to design contracts. You have to find legal ways to work together. And that's exactly what you can find in the legal decision support tool. It's actually a set of templates, contract templates that you can look into. And finally, the energy management platform is a software tool, advanced software tool that will show you objectively what the energy flows on your site are and what they could be. And that creates transparency. I think one of the speakers mentioned it before, trust, transparency. If you're really talking about energy collaboration, setting up real energy clusters, then you have to know what the potential is, what the benefit, the value added is for each of the participants. And that's exactly what this tool can provide. As I said, we start with 3 sites in Europe, but we boost it afterwards to 10 eco-regions. So in the beginning on those 3 sites, we will basically test the approach and validate that the tools really add the value that we wanted to add, that we can set up such learning communities, that we achieve our targets. Once we validate that, we scale it up to another 7 regions. So we reach 10 regions in all. And if it works there, we will further distribute the approach, if you want, to another 80 regions so that we reach all of the 90 high impact regions that we initially identified. So this is what we are achieving over the next 2 years to go. And I hope to really exchange with the other projects here as well, because this is a huge challenge for all of us in Europe. Thank you.
Thank you very much, Peter. And as you mentioned, the challenge, I will launch a quick poll just to see what the audience think about challenges. And I think this will be something nice also to discuss in the final session, as the idea is to understand in the perspective of the audience which are the main challenges for energy cooperation and waste heat. I know that all projects, Sparks, Incubis, and Races identified some of them, and I think that we agree on a fair amount of them, but it's interesting also to know which is the feedback from our audience. Then I anticipate you that we will be talking about tools. Races provide the assist. Thank you, Peter. This will be the focus of the next session, where SOWOT will be presented by Nick Purshouse, which is a senior project manager at the IS Research and Development, and his focus is on built environment and intelligent communities. So you can see that people are voting, and here I'm going to close in 5 seconds the poll. So if you have not voted yet, please do so. Okay, I can anticipate you that the main challenges are here. You can see them in the economic and organization areas, not neglecting technical and awareness. Legal, it's a little bit less stressed. So Nick, please, you should be able to share your screen now, and please keep the time. We are a little bit late, nothing crucial. We can see your screen, I guess not the first one. We cannot hear you, Nick. No?
Okay.
Okay.
Can you hear me now?
Yes, but we don't see the screen or your camera. Now we see the screen. That's great.
Okay.
Okay, and can you just see one slide full screen?
No, we don't. We see it in presenters mode now.
Yes. If you can switch now.
Better now?
We are seeing it, but not full screen. It's in presenters mode, I think, and we cannot see your webcam.
Okay.
We can see your webcam
you should
now.
see my webcam.
And now it's full screen. Perfect.
No, it's full screen. Brilliant. Okay, sorry about that. I'm also in the middle of I live in Scotland, and I'm in the middle of a storm outside at the moment, which seems to be interfering a little bit with my connection. And I will try and move closer to the router, but please let me know if there are connection issues. So hello, my name is Nick Purshouse. I'm from a company called IES, and we do dynamic thermal simulations for the built environment. And as part of SOWOT, we're looking to expand our capability to also include waste heat and cooling for the community. We currently just do sort of have capabilities for buildings and the electricity network, and so we're looking to expand that. The main objective of SOWOT is to develop and demonstrate a market-ready integrated software, and I emphasize market-ready. This is not just going to be sort of a prototype at the end of the project. We are hoping to launch this at the end of the project into the actual market as a commercial software. And the idea is that you'll be able to select and simulate and compare different waste heat and waste cooling technologies, either just at an industry level, but also to understand how that waste heat and cooling can be used within the wider community, and how you can balance the local forecasted demand and supply, and also how you can integrate sort of the waste heat and cooling with any renewable energy that you may have in the wider community. So we started about 18 months ago. So this month we're about halfway through the project, and that is wrong there. It's actually, sorry, yes, it ends in May 22. So I'll just go to the next slide.
Nick, you are the one
Okay.
who have to pass the slides. Sorry, it's...
That's okay. That's okay. There's a delay. That's okay. Thank you. So the timeline for the project, as I said, is sort of over the next couple of years, and we've currently halfway through the project, and we have done industrial site assessments already. So we actually have 11 demo sites that we're going to be using the software and testing the software on in this project. We've developed a sort of technology database that contains all of the technical and economic parameters concerning different technologies in waste heat and cooling. And we've also specified what the software needs to do, both from an end user perspective and also from I guess an IT perspective. We're halfway through doing some business model analysis and also trying to understand sort of how we can integrate sort of energy performance contracting and also looking at distributed ledger technologies as well into the waste heat and cooling area. Over the next year, we're going to be developing the software and also validating it in all of the different industry and demo cases. And the final part of the project is to do an analysis of the impact and sort of the lessons learned and replicate a lot of the things that we're doing with the demo sites, hopefully across more industries and communities. I'll just talk briefly through some of the functions that the tool will do. You know, there's three broad areas. First of all, you've got to baseline the waste heat and cooling as you have it now in your industry or community to try and understand what the potential is for, you know, for sort of doing this. So the software will have a kind of integrated but minimal data collection associated to it. We'll be able to show lots of different energy flows and what the waste heat and cooling baseline is from an industry perspective. We'll be able to show from a community's perspective what your heat and power supply and demand are, and that is wrapped nicely in a 3D view. Then we also have on the simulation side of things a lot of different technologies, which I'll move on to in a second, to do with waste heat and cooling, and how you can integrate that with renewable energy technology and balancing sort of the forecasted heat and cooling demand and supply. And then the final part of the software is looking at reporting and decision support, where we have lots of different KPIs, whether you're from a financial perspective or an energy perspective or an environment perspective. We'll be able to simulate those and show you results of different technologies. You'll be able to compare those technologies to optimize your solution, and also have a look at what the best business model is to apply that solution. Obviously, we were just seeing before that a lot of people saw barriers in the financial areas, for example, to implementing waste heat in an area. So hopefully this could help with that. This is just an example of the view that we've come up with at the moment and that we've developed within the software already. And this is a Sankey diagram. I appreciate it's quite small, but this is for one of the industries to try and show all of the different energy flows within a factory site, and sort of where the waste heat is, which is in the sort of towards the top right hand corner of this image in red. That's sort of where waste heat, the amount of and quality of waste heat is shown there. So to get to that image, we try and get as much data as we can from the particular industry, but if you haven't got all of the data we need, that's okay. We've developed sort of ways to I guess make that easier to get to this final picture, and that's quite a good I think sort of tool for industries to see. These are all of the different technologies that we're going to try and simulate within the software. So some of these IES can do already, such as anything to do with sort of boilers or absorption chillers, and we can also do organic Rankine cycle as well at the moment. But a lot of the other areas we still have to develop, and we're doing that with the help of academia as well through the project. We've also come up with a methodology already that will guide the user as to which technologies will best suit their industry, or from a community perspective, how they want to kind of look at waste heat supply and demand at a community level. So I'm not going to talk through all of these, but we have developed quite a nice methodology that and scenarios that people can select and simulate. And then finally, these. Thank you. I'm near the end. I've got one more slide. And then finally, at the end of this, these are just examples of how a user might view the results. We've also got 11 demo sites, as I said before, across a number of different countries and different industry sectors. So we're covering quite a few bases here. And then finally, the project has a number of targets associated to it, which I'm not going to talk all the way through. I'll just let you see some of those. And obviously, at the end of the project, I think the big impact is really the final couple of targets there to reach a large number of industrial sites and communities by the end of the project, and then from there to try to trigger a lot of I guess jobs and further use of and implementation of waste heat and cooling technologies through this project. And that is the end. Thank you very much.
Thank you very much, Nick. I anticipate there are a few questions for you that you will see later. Zenaida, you should be able to share your screen. Zenaida Morao is the head of the energy group at INEGI, with expertise on sustainable energy use and health in the building environment. Zenaida, the floor is yours.
Thank you, Francesco. I hope you can hear me. I'm going to try and share my screen and see if that's working.
Yes.
So let me know if you can. Can you see my screen now?
Yes, first slide of the presentation.
Oh, it should have been in the right place. I don't know why it's not in the right place. So let's try and. Yeah, let me see if I can do this. Yeah, because I'm already in the correct. I was in the correct. Sorry, it's probably moving as people are presenting. Yeah, let me just see if I can get to the right place. Okay. Sorry, it's taking a little bit. Okay, so I guess you can see the right slide now. Thank you. So Embers was a project that was actually funded at the same time, or it was within the same call as the SOWAT project. So we had basically the same type of requirements, let's say, in terms of what the project should do. In the case of Embers, so it is a project with 16 partners, and we have 7 case studies of implementation. Some of them are similar to the type of case studies that SOWAT also has. We are also planned for a 3-year project, and we have a mix of partners from different backgrounds. So we have industries, research institutions. We also have a couple of institutions that are either sort of making the connection between the private and the public sector, namely related with energy agencies. We also have set companies, research institutions, and so this intermediate profile between the private and the public sector. Our main goals in terms of the development, so we like so what the main goal behind the project is to develop a modeling platform which would identify the feasible solutions for energy, so for excess thermal energy recovery and use, and especially focused on industries, but it can be actually used by other types of users, and we'll see that a little bit in terms of the use cases that we are implementing this tool into. And the idea is to simulate different alternative scenarios for that recovery and use, and also to look at the business side. So what are the advantages, and how is actually that heat that is recovered and also valorized. And the idea is that it should be able to be independently used by a wide variety of industries and other types of stakeholders and users, and in different EU geographies. So I guess we'll have to, okay. So in terms of more specific objectives, the idea is that using the data that's provided by the users of the platform, and this is namely for the industries, but as I said, any other user with access thermal energy would also be able to use the platform. The idea is to, so we have fourfold objectives. So one is to identify who are the relevant users of that access heat within a given geographical area. We'll also be looking into characterizing the type of heat that's available, heat or cold. So it could be any sort of thermal excess thermal flow, and matching the quality of that excess thermal flow with potential demand for at that same quality. The idea is to explore different routes. So if we look here in terms of the implementation, so the idea is to explore different scenarios, which is something that the other projects are also looking into. So it could be the internal reuse of that heat or cold, but it could also be used within other industries, and this would be the scenario where we have the industrial symbiosis. So looking at, for example, industrial park. It could be also to use within buildings, so if anything from commercial to residential or to a combination of those two. And it could also be thought of as being used, for example, in agriculture for greenhouses, which is something, for example, that happens quite a bit. That could happen in some places that have quite a bit of an integrated production of food within their urban environment, for example, as I was just thinking of one example, which is the Netherlands. And the idea is to also, in addition to this assessment of the technological side and for the cost side, also to assess the business models that make all of this feasible, and to look also at some policy instruments that could be used to overcome some barriers to the implementation, which have already been mentioned here also by other projects. So how do we do this? As I said, there is one first step, which is the assessment of the actual quality of let's say, of these industrial flows that's available. And once that's done, so once that assessment is done and the platform will help industries do this, then we have four different types of analysis that are actually integrated within the platform, which allow to look for ways basically reusing that heat. And if we are heat or cold, if we are looking into reusing those streams outside of the plant, of the industrial plant, we have to look, of course, for potential matches within a given geographical distance. So we have a GIS module that looks for the lowest cost path to do that. We then have a techno-economic module, which basically looks into something similar to what SOAT is looking into as well. So looking at this a portfolio of different technologies and different ways of linking basically the sources of the thermal energy and the users of the sinks of this thermal energy. So ways of connecting them and the types of technologies that might need to be deployed to do that. Then we also have a market component that looks into ways of, and this comes from the side of the valorization of this heat or cold stream. So how can we look into pricing options and what sorts of markets would enable this exchange to occur. And finally, on top of all of this is, of course, the business model side, which will do different types of analysis, so financial and environmental and risk analysis. And this the tool is something that can be used in a collaborative mode. So we could have different stakeholders basically adding their own different stakeholders using the same system, but basically adding some potential requirements or constraints from their side, and then running collaborative simulations in order to see what would be the best model to work for that particular system. And just lastly, I just wanted to mention briefly, as I said, we have the idea here is to cover in a way the whole value chain that would be involved in basically the recovery and reuse and the valorization of these excess thermal energy streams. And so we have industry focused case studies, which were initially the main users of the platform. Then we have the network focused case studies, because of course, if we're connecting users and so basically the excess heat producers and the users of that excess thermal energy, and if they're not within the, let's say, within a industrial park or within the same industry, then what we want to do is connect them through networks. And so we have the network focused case study where we have actually some companies in Portugal and in Sweden that are network operators working with us. And also we have in the last type of user, which it's sort of this last chain in the value chain. So we have the super users, which would be more institutions from the policy side and also from the auditing side, who have a lot of information available that could potentially be used in order to identify synergies of heat producers and heat users within a given area. And we also have one case study where we'll be focusing specifically on looking at different types of market structure enablers for the use of excess thermal energy. And these are some of the goals that we have within each one of the case studies. And as you see, there are different routes that we are exploring in terms of the industry, but also different possibilities with the network focused case studies, and of course these the different typologies of then types of stakeholders that could be involved within the case studies. And that's it from my side. Thank you.
Thank you very much, Zenaida. And now I will hand over to Lola from Fundación CIRSE. She is a project manager and researcher focused on energy characterization and environmental performances. I can see your screen. Thank you very much, Lola. And we are concluding this session from what we started the Spark project. Please.
Hello, my name is Lola. As Francesco said, I'm with my colleagues, together with my colleagues from CIRSE Foundation. We have been in charge of developing the Sparks tools. I want to explain very quick what we have developed within the project. The main aim of the tools is overcoming the non-technological barriers that can be found in the energy cooperation services or solutions between companies and within industrial parks. So in this sense, we want to offer this kind of users, stakeholders, raising awareness on energy cooperation issues. On the other side, we want to connect stakeholders all over Europe, supporting the implementation of energy cooperation solutions and assessing and identifying tailored energy cooperation solutions for an industrial park. How we are going to offer this? I'm going to explain it in the next slide. For this, we have developed, first of all, a free online website. We call it a platform, our community, where first we offer like free open contents. There is no need to register to see what is inside. The first one is a section of energy cooperation for beginners, where we explain a little bit what is energy cooperation, what kind of energy cooperation solutions can be implemented in industrial parks, where the companies collaborate between them, the barriers that can appear when the energy cooperation process starts, or even before, and the business solutions that can be done between the in terms of agreement, contracts, etc., between the companies and within the park. Other output we give them is to offer them to show if they have already implemented any energy cooperation solution in a successful way. We offer them to show it through this platform in a section that is called best practices, where here they could gain more visibility for those solutions and also for the parks that have implemented them. After that, I don't know, sorry. Yeah. The other outputs we offer, and I think are the more important, are, first of all, the Sparks initial assessment tool, where we offer to the representative parks and the companies within the park a list of possible solutions, but tailored solutions just for those parks that could be implemented in that park. For that, we ask the park and also the key companies within the park some information to understand their current situation and to show them the list of possible energy cooperation solutions that could fit to them. And also we display some information within each of the solutions. Apart from that, we offer feasibility studies for each of the solutions and also a comparison between them in terms of different influencing KPIs. And this is those KPIs are legal and regulatory, environmental, technical, financial, etc. There are 5. Andrea explained them before when she was explaining Sparks. And if with this information, if the park decide to go for it, go forward to implement this solution, they have another possibility is a matchmaking tool that we call it Sparks Community, where it's a point of meeting between industrial parks representatives and supporting organizations or companies that are willing to support these parks in the implementation of the solutions in terms of legal support, technical support, and even financial support. So they both register, they insert the information is asked for them, and at the end they will find possible matches between them, and they can start to contact and is the starting point for the collaboration. So the interested users for these tools are mainly the park representatives and companies for the the initial assessment tool, and the the park representatives and the stakeholders, so-called stakeholders in the project, but these stakeholders can be companies, consultant companies, organizations, etc. And those two park representatives and stakeholders are the potential users for the matchmaking tool. And finally, the future steps for the tool itself are more that understand what is the industrial park's performance and willingness of participating in energy cooperation solutions, and also act as a first step external facilitator on the energy transition. Start overcome the first barriers they can face. And the main challenge for this is to create a following community that is robust and lasts in the time, and the community starts to have activity. And the future work will consist of providing more support to the industrial parks, giving them the path for possible relations between them, between the park and the companies, and also the local communities through successful business models, cases, and examples. All of this information obtained from Sparks project. And that's all from my side. Mainly it's just to give the support for both industrial parks and companies to start their collaboration between them for the energy transition. Thank you very much.
Thank you very much, Lola. And please let me share my screen now for one last slide I have prepared. And this is one summarizing slide. I think that today you can have seen and heard about these 5 projects. We worked together to organize this short webinar, and we found that there are synergies among us, some superposition probably, but mainly we found opportunities for cooperation. It was one of the theme of today's webinar. Our objectives are common and are to lower the energy costs, to achieve a more sustainable and efficient energy for industries and communities, in order to reduce CO2 emission, as well as increase the cooperation in the Union. In this sense, I'm sure that all projects, all organizations working in this project are open for collaboration. If you found anything especially interesting, you are welcome to contact us. And well, in this slide, there are some key facts about the project, and we will share the slides. Now, I would like to ask the various presenters to just open their camera. We have some questions. We will try to answer. Okay. First of all, let me thank you all you as panelists, first of all, and I have to thank also other people who worked together with us to create and to organize this webinar, both from the communication team and over that. And I hope that we survived the expectation of our audience, which was very numerous. And now there is some question I would like to address you, and please, if there is any other question, write that in the chat, in the question box, and we will try to answer it now or later. The first one is for Nick, I think, and Diana asks that point out that the dynamic simulations can be quite energy intensive to generate, and she would like to know how this is being powered.
Okay, I'm assuming that that's about whether this is done on a powered through a desktop computer, or whether it's cloud-based, rather than kind of what where does the electricity come from to power it. But essentially, the tool will actually have 2 different versions. So there will be quite a, I guess we're terming it as a free basic version, which will be online based, and obviously much less user intensive, resource intensive than sort of perhaps a commercial version, but it will be run sort of through cloud software. And then there's a commercial version that will be desktop based, and yeah, more user and resource intensive, but still trying to keep it as minimal as possible. But it will be powered through your own desktop and downloaded via a license. I hope that answers that question.
Okay, great, thank you very much. And one question to Andrea, it's how about measuring the progress for the KPIs?
Well, we have 2 different reports that we made for the KPIs. One is a general introduction to which KPIs we choose, how we specify them, how we plan to measure them, and how we cluster them. So as I said, we have 6 clusters of KPIs. Overall, we have more than 30 KPIs that actually make up these 6 overall KPIs. And we have a second report, which is a very technical one, in which we actually propose algorithms how to measure each and every one of our 30 KPIs. And in this document, we also make up our mind about how often it makes sense to measure such data before you begin with the project, and then afterwards to actually measure the progress towards achieving your overall goals, and have a quantitative measure to see how well you are developing and in which parts of your solution might make more problems or maybe more successful than others. Both documents, by the way, are fully downloadable from our website.
Great, thank you very much, Andrea. And I do have a question, I guess, from Eric. Diana asks, point out that carbon emission has no geographic boundaries, and most countries signed the Paris Agreement and COP26, but delayed everything due to COVID. And she asks if there are lessons learned to achieve the net zero emission. Difficult one for you, Eric. We cannot hear you.
Yes.
Okay. Now we can.
That's a question from the chat.
Yes, it's among the first ones.
Because honestly, I didn't capture what you told me. So what time was it posted?
11:21. I will just.
Well, I don't see that question. So, is it about carbon tax?
Yeah, well, there are another one about carbon tax. So if you can elaborate a bit on that, this is more than one actually.
But because I don't see the one you are mentioning. So can you please repeat the question?
Yes. The question is, which are the lessons learned to achieve the net zero, also due to the delays which are caused by COVID?
Yes, indeed. That's a big question because member states invest a lot in just helping their economy to survive and to avoid bankruptcies, which is indeed the first thing that is needed. We need to keep at least, well, certainly the companies that were healthy before have to be sustained. Now we really have to think about the recovery after the COVID crisis as not going back to normal, but really taking advantage of the huge funds that will be made available to the member states through the recovery and resilience plan. And so the name itself, recovery and resilience, so meaning that we want to be more resilient after that, not only to COVID crisis, but also more resilient to the climate change, and also prevent climate change, of course, by all the measures that we take. So both in the national energy climate plans that all the member states had to submit by the end of last year and which were assessed by the Commission, and also in the recovery plans that they will have to submit, well, if they wish to access funding, but of course, all of them will do. We already have received some draft plans, and the final plans at the latest are due next year in April. So definitely in those plans there is a requirement that 37% of the funding or loans that are involved in those plans really address the climate change, so measures that combat the climate change. So that indeed the COVID crisis is taking money away because of immediate needs that have to be covered. But on the other hand, huge amounts of money will be made available, and that money will have to contribute to combating the climate. I don't know if this answers your question.
Yes, thank you very much, Eric. And there is a question for everyone, I believe, and it's about if blockchain is considered to drive a solution. I can answer for so what, and the answer is yes, but if I would like to know also in the other projects, and then we can elaborate some section around it. Okay, I guess that might be no. So Nick, if you wish to have a few seconds to elaborate on that, on the blockchain and how it will be used.
Okay, so for the So What project, we're going to be doing I guess a prototype connected to the tool around blockchain and distributed ledger technologies, and so that will be trying to understand how we can actually trade energy between an industrial site or using an ESCO, but actually do that sort of in terms of the monetary transaction, how we actually do that through blockchain. But you know, at the moment, it's a prototype, so that won't actually be part of the sort of commercial solution that gets released. I think this is it's a really interesting area, but it's something that yeah, it's probably a number of years off actually releasing to the market yet. But we hope to try and sort of prove the concept and actually yeah, have a prototype simulation using blockchain sort of during So What.
Okay, thank you very much. Now we are past the time we hoped. So I would just like to launch one last poll about how and if you liked the webinar. So please give us a feedback. This has been the first webinar, the first collaboration among us, basically. It was not extremely technical. This is something we decided to just to avoid a 4-hour webinar, but we plan to go more in deep in technical aspect and hopefully boost cooperation among our project, and we wish that you enjoyed the webinar and you will follow other initiatives. As said, we are more than open to discuss more in deep our projects, and if so, please contact us. You will receive a follow-up email with the information about this webinar and also the our contacts. And we hope to have another webinar probably, or a physical event in the future about our project, and we hope to also present more results as the project will be more developed, basically. So I would like to thank you all, the panelists and the audience, for your time today. And well, I can share the result of this poll. So it was quite successful. I am glad of that. And thank you again for that. And stay healthy in this difficult situation. Bye.
Thank you. Bye-bye.
Thank you.
Bye.
Goodbye,
Thank you.
everybody.
Thank you.
Thanks.
Bye.
Bye.
Bye-bye.
Thank you very much. Bye-bye.